Alright, hello everyone, you're welcome to my channel. So in this video we are going to be, which is of course a live class, we are going to be looking at indices problems. So we are solving we are solving exercises. Recall that the last video I posted on this channel, we solved exercises from a particular textbook, and that was the first part of the exercise or exercises in that book, and we dealt with it from the number 1 of it to the 30th of it. So the book had about that particular chapter, or the sub part has about 30 exercises, and we were able to deal with all of them. So but in today's video we are going to be looking at solving the same from the same book, but this time around we are going to be using solving from the next exercise, all right, which is exercise 1.6. all right, so the one we solved earlier was 1.5, and of course we saw how the exercises progressed, not that much difficult. Okay, so but in this one we are going to be going to the next one, or the next level of exercises, and of course we know it's going to be a little bit more demanding. So but that's why we are here. So we are going to go through it together, and then hopefully it will make sense to all of us. Okay, so you are going to be joining me as I begin with the first one. Okay, so let's go. The first question here is very simple. Okay, I don't know if we should bother, but then of course for the sake of every one of us and for the sake of the tutorial, so this is the question here. We are to simplify, and I believe that these few first questions are just to buttress what we did in the last class, okay, or in the last video, sorry. All right, so let's quickly look at it. So here it says we should simplify this. Of course, you know 4 is to the power of 1. Remember, like I said in the previous video, that this is unscripted, it's clearly unscripted. So we are going to be going through these exercises together. Okay, so here we have, this is 4 raised to the power 1, and then we are told that if you have a to the power of n being multiplied, of course you know bracket is multiplication, so that the two powers we add, so this will give us a to the power of n plus m. So this is supposed to be 4 to the power of 3, and that is the solution. Of course you can expand this to give you, I think, 64. 4 to the power of 2 is 16, and 16 times 4 should be around 64. Okay, so that's just that for this one. And then the exercise 2 is 81 to the power of 3 over 4. All right, we also saw examples like this in the exercise 1.5. okay, so you can put here that this is exercise 1.6. okay, so the name of the book I'm using is the New National Mathematics. New National Mathematics. When the back is done, when I get the name of the author, I will let you know. Okay, so let's go ahead. Okay, so what is this going to be? This is of course what do you call it, fractional index. So where the denominator becomes a root, and then the numerator remains as a power. So this is going to give us the 4th root of 81, which is 3, then raised to the power of 3, and this is equal to 27. Now recall that in that video I also mentioned that you can actually use another approach here. So I can do 81 to the power of 3 over 4 to be, instead of using roots, I can actually change 81 to index form. And in that case, I'll try to see is it possible to get it to an index form that the power will be equal to the denominator of what I have here? Or even if it is not exactly equal to, it should be something that the denominator can divide. And of course, I can write 81 as 3 to the power of 4. And then because there is an existing power here, there is a rule that says that the both powers will multiply. And then of course, that will give you the solution. 4 will cancel 4, so you just have 3 raised to the power of 3, which is 27. Okay, so that's for exercise 2. So we go over to exercise 3. There we are given 3 to the power of 4 all over 27 to the power of 2. So like I said, down to this exercise 3 is just a review of what the exercise 1.5 is all about. So I think from exercise 4, it will a little bit change. Okay, so but let's see how that goes. Okay, so what do we do here? Try to put everything to the same base. So this is 3 to the power of 4, and I can write 27 as 3 to the power of 3 now. And then there's already 2 there, so 2 of them will multiply, and this is going to be 3 to the power of 4 all over 3 to the power of 6. But then again, here I have a division of index numbers, and like I said in that video also, if a raised to the power of n is divided by a to the power of m, this is going to give us a to the power of n minus m. And then of course this will be equal to 4 minus 6, which is going to give us 3 raised to the power of minus 2. You can actually stop here, or you can simplify that further. Let me remove this. So you can simplify that further to give us 1 over 9. How did I get 1 over 9? The rule of negative index, where we are told that a to the power of minus n is the same thing as 1 over a to the positive power. So if I write this as 1 over 3 to the power of positive 2, and then 3 to the power of positive 2 will give us 9. Okay, so that's how I got that. Okay, quickly, we move to exercise 4. Meanwhile, like I said, there are 32 exercises in this one, so we may or may not finish all of them. Okay, so the number 5 or 4, sorry, says that we are giving 64 to the power of 3 over 2, and then multiplied by 64 to the power of 1 over 3, and then everything is raised to the power of 3. Everything is raised to the power of 3. So what are you expected to do here? Okay, now there are a number of things you can do. First of all, you can decide to join these two since the bases are the same, or you can decide to open up this bracket, and you know that if I have a to the power of n multiplied, or sorry, all raised to the power of m, I've actually been using it here, that this is the same thing as a to the power of n times m. That's actually what I used here. Okay, so you can do that and allow 3 to multiply all these powers, or you may choose to join these two first, which I think is better. So since the bases are the same, we choose one of the bases, and then we sum the powers, which is 3 over 2 plus 1 over 3. Okay, and then everything is still raised to the power of 3. So if we join the powers now, let's do that somewhere here. 1 over 3 plus 3 over 2. The LCM is 6. Okay. Then here we will have 3 into 6 is 2, plus 2 into 6 is 3. So 3 times 3 is 9. So here we'll have 11 over 6. And so that's going to give us 11 all over 6, all raised to the power of 3. And so at this point now, Okay, so at this point now, remember to close this bracket. So if you open this now, this 3 will now cancel out this to give us 2. So we just have 64 raised to the power of 11 all over 2. Is it a good place to stop? Maybe, but then of course you can actually progress a little bit, because I can write this 64 as 8 raised to the power of 2. Okay, so why did I choose 2? Because of course you can write this as 2 raised to the power of 6. You can also write it as 4 raised to the power of 3. But I chose 8 to the power of 2 because of this denominator. And then of course it will multiply the existing 11 over 2. Okay, so this will take away this, and so your solution will be 8 to the power of 11. And that's a beautiful place to stop. So that's the solution to that exercise. Okay, so we move over to exercise 5. Okay, so exercise 5 here, this is what we are given. 5 to the power of minus 1. Then everything multiplied by 5 to the power of 2 over 3. And then all raised to the same power of 3. Okay, now if you watch, okay, the previous exercise we did was raised to the power of 1 over 11. I think I missed it up with this one. Sorry, this is 1 over 11. 1 over 11. So that means we shouldn't have gotten to this place. Sorry about that. Okay, so let's correct that. Okay, I think is the number 4 is the one that is to, sorry, number 5 is the one that has power 3. So this, remember we got 6 here, so this was 1 over 11. That's what they gave here. Okay, so you see what would happen here. 11 will take away this 11 here, so we just have 1 over 6. And here I said that earlier that 64 can actually be written as 2 to the power of 6. So have you seen now I had to use 2 to the power of 6 because it did not, the power here is 1 over 6. And when they multiply, so 6 will cancel 6. Sorry, the answer should be 2. Thank you very much. Okay, so let's go on here. So in this place, we are going to have what now? Okay, so here it is good to allow 3 to come in, because what you have here is minus 1 and here is 2 over 3. So the 3 can easily remove this fraction. So here we are going to have that this 3 will multiply minus 3 to give us, minus 1 to give us minus 3. Then times, it will also multiply this power to give us 5 raised to the power of 2, because it will cancel out this 3 here. And so this is just going to be, you are going to have 5 to the power of minus 3 plus 2, because they are the same basis and they are multiplying. So that's going to just give us 5 raised to the power of minus 1, which is the same thing as 1 all over 5. Okay, so we go again to the next number, which is number 6, and there we are given 8 raised to the power of 1 over 4. Okay, so 8 is to the power of 1 over 4, and then we have multiplying 125 to the power of the same 1 over 4. Now multiplying 10 to the same power of 1 over 4. And we are to simplify this. So what is this one going to be? Remember, we have, I call this distributivity of power, where you have a times b raised to the power of n is the same thing as a to power n and b to power n. So meaning I can actually open this bracket and the power will come on the two of them, even if there are 3 or 4 or 5. So multiplication allows power to distribute over them. So that means here the power has already distributed, so I can actually open one bracket and then allow only the bases to multiply. So here I will have 8 multiplied by 125 multiplied by 10, and then everything is raised to the power of 4. Okay, so what is going to happen then now? Raised to the power of 1 over 4, yes. Okay, so what's going to happen here? I will try to see if I can multiply this, will it be okay for me, or I should change them to index form. This is 2 to the power of 3, and this one is 5 to the power of 3, while this one is 10. And of course you can see that something is happening here. 10 is the same as 2 times 5. Wow, this is so beautiful. I love this exercise. That's why I said it's unscripted. So we are just seeing the solution here and now in this exercise as we are solving. Okay, so, and what are you seeing? Are you seeing what I'm seeing here? You can clearly see here now that there is 2 to the power of 3 and 2 to the power of 1 and 5 to the power of 1 and also 5 to the power of 3. So I can multiply these two now. That's 2 to the power of 3 and 2 to the power of 1. And that means equal bases. You add their powers, which will give you 4. And then again, the same thing will happen to 5. 5 is to the power of 3 multiplying 5 to the power of 1. So the powers will also add. So you just have everything to the power of 4. You discover that the solution to this will eventually be 10. This is so nice. Okay, so what happens here? Now remember what I just said here immediately. So I'm going to now open a block bracket, and I'll try to bring out the powers here, which is 2 times 5. So the powers, there is power 4 here. So I'll bring it out. Remember that everything is raised to the power of what you have here, which is 1 over 4. And immediately this power will cancel this denominator here because they will multiply. And so you only have 2 times 5 left, and your answer is 10. So you see how beautiful maths is. Very beautiful. From the onset, it wasn't looking like the answer to this was going to be 10. But then as you continue solving, you will get to see what the solution will look like. Okay? Alright, so this is so beautiful. If you have any question, you can ask me, or you can drop it in the comment section. Alright, so that is for exercise 6. I love this exercise so much. Okay, now let me write the exercise 7 here. They decided to come down a little bit on exercise 7, so which is just a follow-up of what you have done. Okay, so here this is the way they wrote it. Alright, so they are asking us to simplify this. Of course, the bracket that separated the power from the base didn't change anything. So this thing is still the same thing as 2 to the power of 3 times 5 to the power of 3. Okay, and like I said, you can bring out the powers, and you have 2 times 5 all to the power of 3, and then your answer is going to be 10 to the power of 3, which is actually 1000. Okay. Alright, so that's that about that. And then let's go to the next one, which is exercise 8. Okay, exercise 8 is also simple, and I'm going to I think I'm going to leave exercise 8 as an exercise for you. So here we have 1 over 2 to the power of 4 multiplied by 2 over 3 to the power of what now? To the same power of 4. Okay, so that means it's similar to exercise 6 and 7. Okay, so look at that. Let's go to 9. 9 looks alike, and I'm also going to leave it. 100 to the power of 1 over 3 multiplied by 5 over 4 to the power of 1 over 3. Or we can do this together. Alright, let's go ahead and do this. So what is it going to be? we will open a bracket and then multiply the basis. Let me use this. So if we multiply the basis, which is 5 over 4 times 100, and then we will bring out the power. The power is over all of them. Okay, so what's that going to give us? Very easy. You can clearly see that 4 can divide this, and this will give us 25. So, and 25 times 5 is 125, all raised to the power of 1 over 3. So the beautiful thing you're seeing here is that these questions are usually structured in such a way that it will give you beautiful solutions if you follow it carefully. So this is going to be 125, we know, is the same thing as 5 to the power of 3, and then you are done. So it will all multiply, that this power will multiply the existing power, and so 3 will cancel away 3, and your answer is 5. Recall what I said in the previous video, that of course I'm going to add this video to a playlist together with that previous one, so you can actually refer to that one, and I will also put a link to that video to this one. Now, what I said in that video is that the reason we are doing these exercises is that the mastery for solving problems comes from solving a lot of them. Especially in mathematics, try to solve a lot of problems. That's why it's good you can come to channels like this. You can buy textbooks that have exercises. Try to solve exercises. It helps you master the concept. Okay, so let's go on, and then we have the 10th one. Okay, so if you have any question, you can always ask in the comment section, and then of course I will respond to it. Okay, all right, so let's go on. Okay, so the number 10 exercise says that you are given 6 to the power of 2n plus 1 multiplied by 9 to the power of n, then multiplied by 4 to the power of 2n. Everything is divided by 18 to the power of n multiplied by 2 to the power of n, then multiplied by 12 to the power of 2n. Okay, so what are you expected to do here? This is also to simplify. Okay, so it may not be to solve. So here we are just simplifying, because to solve there will be an equation. Okay, so let's go ahead. So what do we do? Okay, so we try to start by simplifying the basis. Okay, here I have a something I can write in index form. This can give me 3 to the power of 2. This can give me 2 to the power of 2. This also cannot go to any base. It can't go to any base where the power will be an integer. The same thing with 18. But I am seeing something. We can actually split this, and it will have 2 and 3. So let's begin. Okay, so I can actually split 6 to give me 2 times 3. Let me use dots to write that multiplication. All right, and all is raised to the power of 2n plus 1. Then multiplied by 9 is 3 to the power of 2. The 2 will multiply the existing power, so you have 2n. And this is multiplied by 4 is 2 to the power of 2. That 2 will multiply the existing power, and you have 4n. Okay, so this is all over 18. The same thing that happened for 6 can happen here. I can write 18 as 2 times 3 times 3 again. That's 2 times 9. So I can actually write it as 2 times 3 to the power of 2. Okay, I hope that is clear. The power is still n, so multiplied by 2 to the power of n. And the same thing will happen to 12. I can write 12 as 2 times 2 times 3. Please, you can be checking out this to be sure you are cleared on that. So, and then 2 here can now be written as power 2 multiplied by 3 all raised to the power of 2n. Wow. I think I am beginning to love the demanding nature of these recent exercises. Remember I told you that from 1 to 4, 5, and all of that, even up to 9, are all reviews of the previous chapter. Okay, so, or previous section. Okay, so let's go ahead now. So what do we do here? So we can open all the brackets. So if I open the first bracket, I'm going to have, let me use this. So I'm going to have 2. Remember, the power would distribute on the 2 of them. So you have 2 to the power of 2n plus 1 multiplied by 3 to, or let me use white or blue to write the 3. So I'll have 3 to the power of 2n plus 1 also. Then multiplied again, you bring down these 2, which is 3 to the power of 2n, and then 2 to the power of 4n. Okay, this is all over. You will do the same thing below. So starting from 2, so I'll have here n will come on them. So I'll have 2 to the power of n, and then 3. I'll have 3 to the power of there's already power 2 here, so it will multiply the n to give you 2n. Then multiply by 2 is already here, 2n. Okay, so I'll write 2n, or okay, I'm using yellow to write 2. So let me maintain that, 2 power n, then times. Now you open up this bracket, there is 2 to the power of 2. So the already existing power will multiply this one. So you have 2 to the power of 4n. Then finally multiplied by 3. The power there is 1. So it will just be 3 to the power of 2n. Wow. This is beautiful. Okay, so what's going to happen finally? So we'll try to see if we can now collect what we are. First of all, check if there is anything that can cancel before collecting. Okay, like here I can see 2 to the power of 4n, can remove this. I can see 3 to the power of 2n, can remove this. Nothing else can remove here. So, and then we only have 2 up, 2 down, 2, 3 up, 3 down. So we can now apply our division rule. Let me use white to do that now. And our division rule says that the powers will subtract. So I will have 2 to the power of 2n plus 1, then minus n. That's the power below. And the same thing will happen to 3. So I'll have 3 raised to the power of 2n plus 1, then minus, in this case, it is 2n. So you are subtracting 2n here. So meanwhile, let's go up and be sure. Okay, so we are sure. Okay, so, and then finally you simplify what you have. So you just have 2 to the power of, okay, sorry, C. I would have said, because this should have been giving us something beautiful. We are omitting this power here. Sorry about that. Let me remove this for now. So we are neglecting this. You're actually supposed to join the 2 of them. And when you join it, it will be n plus n, which is 2n. So the denominator here should actually be 2n. So it will be minus 2n also. Wow, this is nice. Okay, so this 2n will remove this 2n, and this 2n will remove this 2n. So you just have only 2 to the power of 1 multiplied by 3 to the power of 1, which will give us 6. Jesus. Oh my God. What a problem. What an exercise. This is so beautiful. The whole of this ran down to 6. Wow. Wow. This is beautiful. Wow. Wow, 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 wow. We got 6 here. Oh my God. Oh, so this is amazing. And if there is any question, please don't hesitate to ask. Okay, so we move on. That's for exercise 10. Okay, is it 10? Yes, that is for 10. So we go to exercise 11. And 11 says we have 4 into 2 to the power of n plus 1, okay, close the bracket. Then we are given minus 2 to the power of n plus 2 all over, here we are given 2 to the power of n plus 1, and then minus 2 to the power of n. Okay, so what did they expect us? We are still simplifying. Okay, the question actually says simplify each of the following, and that's from 1 to 11. Okay, from 12 now they said evaluate. Okay, so let's go on now. Okay, so we have what do we do here? Okay, so here is looking like something we would need to do some substitution. Okay, first of all, in this case we will need to interpret what we have. 2 to the power, or let's say this, a to the power of let's say n plus m is the same thing as a to the power of n times a to the power of m. We saw that in exercise 1. So that means I can split this one to give me 4 into 2 to the power of n times 2 to the power of 1. Beautiful. Now minus, I can split this one to 2 to the power of n, times 2 to the power of 2. Okay, this is all over. The same thing will happen here, 2 to the power of n dot 2 to the power of 1. While you have minus 2 to the power of n. Okay, this is amazing. So what do? You can try to factorize, okay, because here I have, okay, permit me to start from here. Okay, so here I have 2 to the power of n, 2 to the power of n. So I can bring out 2 to the power of n and then open up a big bracket. And if I do that, from this first part, the 4 will be left there, and the 4 will be multiplying this 2 that is also left here. Then minus, on this side, only 2 to the power of 4 will be left. 2 to the power of 2. And 2 to the power of 2 is 4. So you can close this all over. You also bring out 2 to the power of n here. So in bracket you will have here only 2 to the power of 1 will be left, which is 2, minus here, if you divide by 2 to the power of n, you have only 1 left. Beautiful. And so what will happen? The 2 to the power of n will cancel themselves, and so I just have 4 times 2 here, which is 8, minus 4 is 4, all over 2 minus 1 is 1, and that means our solution is 4. Wow, this is beautiful. This is just beautiful. Okay, so what happens is that our solution here is 4, and that is the answer for number 11. Okay, so we'll move to a new page. This page has exhausted. All right, so for the number 12, what do we have? We are given to evaluate this time 8 to the power of 1 over 3 multiplied by 5 to the power of 2 over 3 all over, here we have 10 to the power of 2 over 3. Okay, be looking at it. Just give me a few minutes. Be looking at this while I come back. All right. All right. Let's go on now. So here we have this exercise, and it says that we are to evaluate this. And how do we evaluate this? We will, of course, do the same thing we have been doing. Try our best to see, is it possible to reduce them to give similar stuff. Okay, for instance, here I can reduce 8 to give me 2 to the power of 3. And then the power will multiply the existing power here, which is 1 over 3. Then multiplied by, I can still retain my 5 to the power of 2 over 3. And this is all over here. I can still retain my 10 to the power of 2 over 3. Let's see what that is going to do for us. So from here, what do you do? So you can clearly see that 3 will cancel this 3 here. And if that happens, if 3, okay, yes. Okay, if that happens, you just have only 2 to the power of 1 here, multiplied by 5 to the power of 2 over 3. All right, so now we can actually split here. I think we should have done it earlier. Let me do it before moving on. We can split that 10 to 2 times 5, all raised to the power of 2 over 3. So that at this point now, the power will distribute on these numbers here. So 2 will be to the power of 2 over 3 times 5 to the power of 2 over 3. We have not changed anything. What we have here is still the same. Okay, so, and what will that do for us? So we can clearly see that 5 to the power of 2 over 3 will cancel 5 to the power of 2 over 3. And those ones are gone. So we just have only 2 left. And that will be 2 to the power of 1. Because this is division, you will subtract the powers. So you have minus 2 over 3. And that's going to give us 2 to the power of 1 all over 3, which you can write as cube root of 2 if you want. But then how did I get 1 over 3? That's 1 minus 2 over 3 would definitely give you 1 over 3. All right, and that's the solution for exercise 12. So we move on to exercise 13. So for number 13, we are given 0.008 raised to the power of minus 1 over 3 multiplied by, here you have 0.16 raised to the power of 3 over 2. Beautiful. Okay, and that's what they asked us. Is the 2 over 3 looks like minus also. Okay, so I think it's negative also. It's not very clear there. So let's go ahead. So what are we going to do here? Remember what I said in the last class or in my last video, that whenever you are given a decimal, always change to fraction. Or you are given an improper, a mixed number, always change to improper fraction. It's important. So this is going to be, how do you change that? You have 8 all over. Just write 1. I said that in that video. And count the number of digits after your decimal point. And here we have 3. So you will attach 3 zeros, all raised to the power of minus 1 over 3, multiplied by, we do the same thing here, 16 all over 1, this time around 0, 0, all raised to the power of minus 3 over 2. Beautiful. So what do we do? Where does that lead us to? So we will try to see if we can clear the negative powers. And yes, we can. And how are we going to get that? Okay, I don't think that, let's look at this. I think it is positive 3 over 2. Please, let's remove this. Okay, it's positive 3 over 2. So what can we do here to clear this? Remember I said in that video also that if you have a over b all raised to the power of a negative power, that you can actually turn over the fraction, and then you will clear the negative to positive. So this is equal to b over a raised to the power of n. And if that is so, I can actually do that here. So I'm going to get 1000 all over 8, all raised to the power of, this time around it will be 1 over 3, multiplied by 16 all over 100, all raised to the power of 3 over 2. All raised to the power of 3 over 2. Okay, so that is that. And so what do you do next? You will now try to apply your fractional index. So this is just cube root. Maybe we can just go ahead and do that. The cube root of 1000 is 10, and the cube root of 8 is 2, multiplied by, this one will be square roots, and then you still take the cube. So the square root of 16 is 4, and the square root of 100 is 10. Now remember, the numerator is still 3, so you still keep it as power 3. Here I didn't bother keeping this because it's just 1. Okay, so what will happen next? This is now going to give us 10 all over 2 multiplied by 4 raised to the power of 3 is 64, and 10 raised to the power of 3 is 100, and then, 1000, and then you try to cancel out. So 2 will cancel out 64 to give us 32, and 10 will cancel out 1 here, so you just have 32 over 100. So you try to see, can we reduce it further? Yes. 4 can divide 32 to give us 8, if I am correct. Yes. And then divide 100 to give us 25, and this is our solution. Okay, so that is the solution to number 13. Okay, so let's look at number 14. Okay, example 14 or exercise 14 here says 8x, the x is raised to the power of minus 3, then multiplied by, you have 3x squared all over, this one is 6x raised to the power of minus 4. Beautiful. So this is what we are asked to evaluate or simplify. So what do you do? Remember what I said, or if you have not watched that video, please ensure to do that. Numbers, in this case, once you have a mixture of number and alphabet, which is algebraic, all you do is numbers should multiply numbers, alphabet should multiply alphabet, numbers should divide numbers, alphabet should divide alphabet. So here, 8 will multiply your 3 to give us 24. Then x will multiply x, and that will just be the powers we add. So you just have minus 3 plus 2. All over here you have 6x raised to the power of minus 4. Okay, and you are close. So here 6 can divide 24 to give us 4. And so we have 4, and then x. Now remember that this one will give us minus 1. So we can just remove it and replace it with minus 1. Okay, and so here is going to be power minus 1. Then remember that division changes to subtraction. So this is going to be minus 4. Beautiful. And so our final answer is 4x raised to the power of minus 1. Minus here is plus 4. So minus 1 plus 4 is going to be power 3. And that is the answer for number 14. Okay, and straight away we go over to the next one, which is 15. And so 15 says that we should look into this one. Simplify 4a raised to the power of 3 times b to the power of minus 1 times c, everything to the power of 2. Wow. Then multiplied by, here we have another bracket, a to the power of minus 2 multiplied by b to the power of 4 times c to the power of minus 2, everything to the power of half. Then all over, here we will now 64. This question is beautiful. A to the power of 6, B to the power of 4, and C to the power of 2. All raised to the power of minus half. Wow. Okay. And we are to simplify this. Right? Let's see what is going to be. So here we have a very nice problem. Nice problem. Okay. So what do? We try to open the brackets first. So when you open the bracket, remember the power here will come on all the powers. It will multiply all the powers. So why am I opening brackets first? Because there is practically nothing you can do if you don't clear the brackets. Alright, so that the things can interact with themselves. Okay, so these 2 will come on 4, you have 16. 2 will come on power 3, you have 6. 2 will come on power minus 1, you have minus 2. And then you have C to the minus 2. Let's have times, let me use another one. Half will come on minus 2, I'll have minus 1. Will come on 4, I will have 2. Will come on minus 2, I'll have minus 1. Beautiful. All over, let me use white still here. So 64 will come down. So half will come on 6, you have 3. Half will come on 4. Sorry, it's minus half, so this should be minus 3. Minus half will come on 4, you have minus 2. And minus half will come on 2, you have minus 1. Beautiful. Alright, so let's go. This is going to be equal to, okay, so at this point, we can see that 16 can cancel 64 here to give us 4. Okay, that would be nice, at least to reduce our what we are carrying. So we just have only A's and B's and C's in the numerator. So let's begin to multiply our A. So A here will multiply this A here. The powers will add. So, and of course, 6 plus minus 1 will be 6 minus 1, which is 5. Then B, we have minus 2 plus 2, which will be 0. In fact, that is supposed to disappear, but let's just leave it there for now. Then we have C. C will be 2 plus minus 1, which is 2 minus 1, and that is 1. Wow. So our numerator is simpler now. So we go to the denominator. We just have 4 A raised to the power minus 3, B raised to the power of 2, minus 2, and C raised to the power of minus 1. Okay, nice. So what do we have as our final answer? This is nice. Okay, bring out the number. Remember, there's an invisible one here actually. Okay, now, what will be the power? 5 minus 3. Remember that division is minus, so you are subtracting the powers. So we come to B. B is 0 minus 2. Okay, then we come to C. C will be 1 minus 1. Okay, and you are done. Your final answer will be 1 over 4 A raised to the power of 8, because this will be plus 3. Then B raised to the power of 2. Then C raised to the power of 2 also. And this is your solution. And you can choose to write it in other forms, depending on what you have. If it's an objective exam, I can choose to write it in other forms. And what other form can you have? You know that 1 over 4 is the same thing as 1 over 2 all squared. Something like this. If you open this bracket, you still get back 1 over 4. So that means I can write this as 1 over 2 all squared. 1 over 2 all squared. And if I do that, so it means that I can actually factorize out square from all of these things. So I can have 1 over 2 times A. If I bring out 2 here, that's I'm dividing by 2. It will be power 4. If I divide by 2 here, it will be power 1. If I divide by 2 here, it will be power 1. So everything here is raised to the power of 2. So either I write it this way or I write it this way. Remember that this one is actually 1 over 4. Please, it's better that way. So it's either I write it as 1 over 4, all of this, or I can write it this way. I only put that 1 over 2 to the power of 2 to show you something. All right. So, and this is the solution for exercise 15. Yes. Okay. And I'm going to write exercise 16. And I'm going to leave that 16 as an exercise here. Number 16 as an exercise. We are given cube root of 8a to the power of 3, b to the power of 6, the cube root closed there, then divided by, here we now have square root of 1 over 25. Let me use another color here. 1 over 25 multiplied by a to the power of 4, then b to the power of 7. Then here we have multiplied by another square root, but in this case there's a bracket of 16 square root of a to the power of 4, and then b to the power of 6, and everything raised to the power of half. Okay, permit me, I think this power 7 here may not be in order. Let's take it to 8 so that it will be something divisible by 2. Okay, I'm going to be allowing you to look into this particular exercise here, and then that will be a break for us in this lesson. I am going to start after our break from number 17 to number 32. So it means we broke the exercise into 2 parts. So we started from number 1. And then we got to number 16. So this is exercise 1.6 from number 1 to number 11 here. Then we moved over here, continued from 12, and we got to number 15. And I'm leaving 16 as an exercise for you to just try to do something with it, and we will be back after a small break to continue. Have a very nice day. See you in our next class. Bye.